All right, what up, everybody? This is Mr. Stan coming at you with another video. This time we're in part three of a series on how to calculate work. All right, so method three is unlike the first two methods in that you don't have to know how much force is being used. In method three, we just use the definition of work, which is change in energy. Okay, because work is something you do to change the energy of something else. So if you know how much that something else changed energy, you know how much work you did. So work is equal to change in energy, which means it is equal to the energy that something has after you do work on it minus the energy it had before, because that difference in energy is the work that you did. So let's look at an example. Sir Roach is back, and this time he's pushing his 0.2 kilogram ball up the top of a 2-meter high ramp. It takes 80 seconds to reach the top of the ramp. Right, so notice we're not told anything about how much force he has to use to push this ball up the ramp. Right, we're just told that it makes it to the top. So we can use this third method to calculate how much work Sir Cockroach did to get his ball up there. The work is equal to the change in energy, which means we need to know how much energy the ball had at the end and how much energy it had at the beginning. Okay, well, at the end, it would have had gravitational energy because he pushed it to the top. It would be there at the top of the ramp, and assuming he came to a stop at the top of the ramp, you would only have gravitational energy. At the beginning, it would have no energy because it's on the ground, not moving, and he comes along and pushes it. So whatever the difference is between those two states, that would be how much work he did to push it up to the top of the ramp. So we know the equation for gravitational energy. It's mass times gravity times height. And so if we plug in the numbers that we have, we get that right there. Okay, 0.2 kilograms is the mass. Gravity, we're rounding to 10 for gravity on Earth, and then the height of the ramp is 2 meters. So notice we don't need to know how long the ramp is, right? All we need to know is how far up he pushed it, because that determines how much energy he gave to it. And so the work would be those three numbers multiplied together is 4 joules. And we can also find the power because it tells us that it took 80 seconds for him to get the ball to the top of the ramp. So if we do 4 divided by 80, work divided by time, it gives us 0.05 watts of energy. All right, so with this method, we're able to find the work done even without knowing how much force was used, just by looking at the change in energy of the other object. Okay, not the one doing the work, but the one that getting the work done to it. All right, so that's how you calculate work, and I will see you all in another video.